Hey everybody, we're getting started with chapter 10. This is about the muscle systems. So a bit of an overview to the human musculature in general. Muscles make up about half of a person's body weight and are central to humans' health and fitness overall. So they're a very, very important body system for us to be learning and talking about. In this section, section 10.1, corresponding to your textbook, we'll be talking about the different functions of muscle tissue. We'll talk about the connective tissue compartment that the muscle tissue is situated in and its relationship to how muscles are organized. We'll talk about muscle fascicles and how the shape of those fascicles relates to the relative strengths of various muscles. And we'll also talk about how muscle bone attachments work and some of the shortcomings when we're talking about origins and insertions. We'll also be looking at the difference between intrinsic and extrinsic muscles. We'll talk about ways that muscle groups work together and can have a synergistic aiding effect, can oppose each other, or can moderate each other's activities. We'll talk about how nerves innervate the muscles and allow voluntary muscles to move, and the blood supply that flows to skeletal muscles. And we'll also talk about some of the naming conventions for muscles. So there are some functions of muscles that I'm sure are very familiar to all of us, and then some functions that may be not quite as familiar. So obviously muscles, skeletal muscles, voluntary muscles in particular, are involved in movement. They help us get from place to place, to lift things, to move things. They also are important in a lot of our other more autonomous body functions, things like breathing, our blood circulation, digestion. And these things are less related to skeletal muscles, generally speaking, than smooth muscles and cardiac muscles. Movement of muscles is also critical in communication. Think of all the different facial expressions you can make and how it's your muscles that change the position of your facial features and allow you to have those expressions that communicate how you may be thinking or feeling. More explicitly, speech, the movements of your mouth and tongue and larynx are controlled by muscles. Writing, all the small muscles in your hands and wrists and forearm that go into writing allow you to communicate in that way as well. Your muscles also allow you to maintain your posture and keep you stable and steady. We have specific anti-gravity muscles that keep us upright and muscles that stabilize joints and maintain the tension that allows those joints to be immobile when we want them to be for a given time or activity. Muscles also control openings and passageways. We have round internal muscular rings called sphincters in the body that control how food moves through the body or blood moves through the body, and sometimes other materials as well. As much as 85% of our body heat is produced by our skeletal muscles. Okay, so maintaining that homeostatic 98.6 degrees approximate body temperature is in a large part due to heat production by your muscles. Also, muscles are able to store and release as necessary glucose in the form of glycogen, and this helps to regulate your blood sugar when you are between meals or exercising. Humans have approximately 600 skeletal muscles. We already said that they account for about half of a person's body weight. And we've also talked previously about the three main kinds of muscle tissue. So we have the voluntary skeletal muscle, we have cardiac muscle that's found in your heart, and we have smooth muscle that lines blood vessels and your digestive tract, among other things. Generally speaking, the big major purpose of muscles is converting chemical energy that is stored in ATP into mechanical energy to do some sort of motion, whether that motion is contracting the heart or extending your leg to kick a soccer ball. We are converting ATP, that mechanical or that chemical storage molecule, into some sort of motion. And this word is pretty important for us. We want to know that myology is the study of the muscular system. And this is a word that can easily be confused. There are other words with similar roots. Specifically, mycology is the study of fungus. And I made the mistake of trying to talk to one of my master's advisors about mycology, meaning muscles, and really kind of embarrassed myself. So don't make my mistake. Myology is the study of muscles. Okay, so here we have a pretty good picture of the muscle system as a whole. We have the whole skeletal muscle, and then we can look at individual muscle fascicles. Okay, and muscle fascicles have nerves and blood vessels associated with them that are found between the fascicles. Then we have individual muscle fibers inside the endomysium. Okay, and then if we look at a muscle fascicle and pull out an individual muscle fiber, we'll be talking about the structures that we see in each of these individual layers. Okay, so looking at some of the connective tissues and compartmentalization of muscle structure. We start with the endomysium, which is loose connective tissue. We find it around every muscle fiber. And this endomysium has, essentially, it's a space for capillaries to bring in oxygen and exchange that for carbon dioxide, and also allow for nerve fibers to act on the muscle. The perimysium is a thicker layer that we find around fascicles. So the endomysium is around muscle fibers. The perimysium is around fascicles. Okay, so a bundle of muscle fibers is called a fascicle. That's very, very important for you to know. And similar to the endomysium, the perimysium gives space for the nerves, the blood vessels, and also stretch receptors. And stretch receptors are going to help you to not overextend your muscles. Our next layer of connective tissue is the epimysium. And the epimysium is the connective tissue that covers an entire muscle. So your epimysium might cover your entire biceps brachii, for instance. Okay, so the outer side of the epimysium is integrated with the fascia, and the inner side of the epimysium can kind of form with the perimysium. So we'll look at a picture of that in a second. So the final thing here is the fascia. And the fascia is the highest order of connective tissue that we're going to be talking about here. And it's going to separate muscle groups from one another. Okay, so if I have a muscle fiber, and this is a cross-section of a muscle fiber, okay, the endomysium is going to go around that muscle fiber. And then the perimysium is going to go around the fascicle. Okay, so here's my fascicle, this broader region. And the perimysium is going to go around that. Okay, shapes of muscles. We can classify muscles by their shapes. So Fusiform muscles, we've seen fusiform cells, right? Fusiform muscles are narrow at the ends, are tapering at the ends, and are bulging in the middle. Parallel are just what they sound like. The muscle fibers run parallel to each other with approximately equal width between fibers at each end. Okay, triangular. Okay, so kind of a fan shape going on here. And they come together kind of symmetrically at one tapered end. Now, pennate, there are three different types of pennate. When we say pennate, we mean feather shaped. Okay, so we could have this unipennate. Okay, so we've got one tendon on one side, and the muscle fibers are radiating out kind of parallel from that. We have bipennate, where we have the tendon and the muscle fibers are extending on both sides of that tendon. And then we have the multipennate. So multipennate has several tendons in here that are all converging on a single point and radiating in three-dimensional space from there. Then we have the sphincters, or the circular muscles. So these are ring openings. And this one here we're looking at around the eye and the eyelid, for instance. So muscles have to attach to bone in order for the muscular system and the skeletal system to work together and provide for skeletal movement. So tendons are the things that directly connect muscle to bone. We use collagen fibers that kind of extend into the endomysium, perimysium, and epimysium. And that allows for attachment to the matrix of the bone. We can also have a direct attachment to the bone, meaning there is very little separation between the muscle and the bone. And in this case, it appears that the muscle emerges directly from the bone without the use of a tendon. So indirect attachments involve a tendon, and direct attachments are a much closer association between the muscle and the bone. We can also describe muscles as intrinsic or extrinsic. And intrinsic muscle is associated all within one region. So a lot of the muscles, small muscles in your hand that allow all of the fine motor skills that you have with your hands, those muscles don't extend past your wrist. Okay, so they're very localized in the region of your hand. The opposite of that is an extrinsic muscle. Okay, so we have some muscles, okay, and there are some muscles in your hands that we consider extrinsic as well. Okay, so these are located in a region and act on a region, but they have an attachment to a bone somewhere else. So if you move some of your fingers, you may see motion in your forearm, and that's extrinsic muscles, where the action is in your hand, but the attachment is in your forearm. When I say action, what I mean is the effect produced by a muscle that either produces or prevents movement. And we have four general types of muscle movement. Okay, we have a prime mover, and in some textbooks you'll see this as agonist. Your prime mover, your agonist. This is the muscle that either as a class 1, class 2, or a class 3 lever that we've talked about before uses force to make a joint move. Okay, then we have synergists. So synergists are muscles that assist the prime mover in going the direction the prime mover wants to go. Okay, the antagonist is something that wants to move in the opposite direction. So a lot of muscles are built as antagonist pairs. That means we have two muscles that are closely associated that move in opposite directions. So a really good example of this is your biceps brachii on the top side of your upper arm and your triceps brachii on the underside of your upper arm. And one of these muscles allows your upper arm to extend and the other allows it to contract. And together, it allows you to have that hinge motion at your elbow. Finally, a fixator muscle is a muscle that prevents movement at a bone. Muscles have to be innervated in order for the signal to move to get to the muscle. Okay, so knowing where and how that innervation happens allows us to make a diagnosis of different disorders. We can use muscle tests as part of the diagnosis of nerve or spinal cord or even brainstem injuries. And we're talking about innervation muscles. We can talk about either spinal nerves that come from the spinal cord or cranial nerves that come from the base of the brain. About 1.25 liters of blood per minute is going to your muscles at rest. So of the blood that's being pumped by your heart, about 1/4 of it is going to sustain your muscle system. This increases drastically when a person is exercising. Okay, so it's about more than 10 times, a little less than 10 times, the blood need when a person is exercising. So muscles have kind of complex names, and they're complex because we're trying to be very specific about the muscles. We have 600 of them, and if they all had short similar names, it could get very confusing. So the names are generally Latin names, and they tell about the structure or the action or the location of the muscle, and a lot of times several of these different descriptors all together. And you'll see as you read your textbook that there's a lot of information about how the muscles got their names and why their names are logical choices. If you have any questions about how muscles are pronounced, take a look at this resource here. Okay, so 600 muscles. This doesn't even show them all in this one picture. One thing that I want you guys to notice is we have a distinction here between superficial and deep muscles, and we can see superficial and deep muscles here on the two sides of the body. Because the muscle system is multi-layered and complex, a lot of times there are muscles that are obscured by another layer of muscles, more superficial. Okay, so your textbook tries to kind of do some almost dissection work in the illustrations to show what's below and what's above other muscles. So make sure to pay attention when your book is telling you if something is superficial or deep. That will give you some valuable information. And we'll wrap up here with a learning strategy. Okay, so your textbook has some really good illustrations. The online textbook has some pictures of cadavers or deceased persons who are being studied for the purpose of learning anatomy. If you can, a lot of these muscles can be felt on your own body. We can compare the muscle system to a skeleton, to the skeletal system to see how they work together. Take a good look at the different names of the muscles and try really hard to see the logic in the name rather than just memorizing the name. If you can think about why a name is logical, that will help you remember it a whole lot more. And studying with a partner is almost always helpful.